Hi, I'm Patrick Shaughnessy. I program video games, and today I'm going to start programming a video game and show you steps in how I do it. What I'm doing here is making the basic scaffolding for a browser game that'll be a 2D game using sprites. And I'm going to do everything from scratch, not using any pre-existing code, not using any third-party libraries, just coding it up right there in HTML and JavaScript. In practice, when I actually do this, I do usually copy and paste some code from past projects, but the demonstration's more interesting if I don't do that. So we're going to get into a directory here and just start editing some files, loading the JavaScript, and having a place for the game to appear on a web page. So let's start with the HTML page. I'm using Emacs for my text editor. It doesn't matter what text editor you use, except it should know things about like syntax highlighting for JavaScript. It should know parentheses balancing, recognize comments. Otherwise, you're just going to end up in a situation where you're going to have a bug and it's going to be really hard to find. So any editor that knows what JavaScript is good enough. So let's make a HTML page from scratch. Alright, HTML should always have a doc type declaration, just so the browser doesn't complain about it being old HTML. You want the browser to complain as little as possible, so when you open the debug window, you don't have to read the complaints, because you're going to be opening debug stuff a lot. So we got a head, we got a body. We need a character set. Doesn't really matter what the character set is, just you want to have one, again, just so the browser doesn't complain. Alright, we don't really necessarily need a title, but let's have one. Okay, then we want a script tag, of course, that will load our script. I'm not expecting the reader to necessarily know every single HTML thing, but I am expecting that if you see something here you don't already know, you'll be able to look it up on your own time. I'm not going to explain the syntax of everything I'm doing. Most of what I look things up is the Mozilla web docs, developer.mozilla.org. That's kind of Firefox-centric, but usually there's a compatibility table telling you if it'll work in other browsers as well. For the most part, I just target Firefox and Chrome and don't worry about other browsers. So, this web page so far, it has a title, it's valid HTML, I think, and it's going to load this JavaScript here, game.js. And there's one more thing I want to throw on this page right away, which is a canvas. When you're doing 2D graphics, you usually have a canvas element on your web page, and that should have a width and a height, and canvas is a tag that closes. So there we go. And if we open this up in our web browser, it looks blank, but if we inspect elements, we can see the canvas does exist on the page. Also, because that game.js script doesn't actually exist yet, we get a loading failed error. So, we have a page, it's just using the default browser color, which happens to be white. I don't care right now because I just want to get everything working. We can style the page later. And we have a canvas with a specified size. Alright, now there's one other thing. We want an entry point for the JavaScript. When the page is finished loading, we want to do something. So let's just have a onload handler on the body of the page. What that's going to do is, after it's done loading this HTML file and loading the JavaScript, loading anything else dependent on this page, then it will call this function in the JavaScript file. You don't want to call your JavaScript when you don't know things aren't loaded yet, because that may or may not work and it can be annoying. Like you get bugs where you get the bug depending on how long things take to load. So I'm starting a JavaScript file, and because I'm using modern JavaScript, I am starting with the words use strict in quotes. That tells it that if I do something stupid that JavaScript shouldn't allow, it should actually not allow it. The biggest thing is if you declare a variable and you forget to actually declare the variable, without use strict, it'll default to being a global variable, which is almost always the wrong thing to do. So you want to use strict, so instead it'll just be an error. You have to explicitly declare your variables when use strict is on, which saves a lot of bugs. Okay, so we've got HTML with a canvas. Oh, this canvas, we want to be able to refer to it. So let's just give it an ID and just give it the ID, which is also the string canvas, because that might be confusing. Let's call it game canvas. All right. So we've got this HTML page. We've got this JavaScript. We're going to call onLoad. So we're writing a new function, onLoad. So when this goes off, we'll know it's going into this script and calling this function. And we want to do something with the canvas. Let's just do something with the canvas to get started. How about we do this? Well, actually, let's make the canvas in context some global variables so we can get to them later without having to hunt them down every time. So the first thing we're going to do is find that canvas. Canvas equals document.getElement by ID game canvas. All right, the canvas variable is now pointing at this canvas that's on the web page. And context equals canvas.getContext 2D. A context is how you tell the canvas to draw things. There's 2D context, there's WebGL contexts, and there's WebGL2 contexts. There might be other weird ones too. For a 2D game, you could use WebGL, but you have to write shader code. If you just want to do very simple draw operations, the 2D context has nice built-ins. You don't have to worry about shaders. You are limited to 2D operations, of course, but that's what I'm doing anyway. We have a canvas, we have a context. Now let's do something on the context. So the context has various members and parameters and stuff. One thing you have is the fill style, which you can set to an HTML color code or a color name. That could be black or $0000, whatever, however many zeros, 6 zeros. And then we can do a fill rect. And let's fill the rect from 00 to canvas.width, canvas.height. And now if I reload the page, now the canvas exists, and that's an old message. If we reload the page, you see we just have this clean, no errors. And the canvas actually is getting drawn on, and to prove that's really happening, let's just say red. Alright, so we have the bare minimum. We have JavaScript that can draw things. Let's draw a thing on another thing now. Let's go red, and let's say canvas.width over 4. Canvas.height over 4. So this fill rect command takes an x, a y, a width, and a height. And so that's going to make a black one the whole canvas size, and then a red one taking up just the middle. Alright, so that's how you do your most basic canvas drawing for just static image, of course, because nothing is animating yet. So we do want to be animating, and that is the next point on my agenda here. Animation. There are two things that happen in animation. Internally, you have your game state, which knows where are all my things, and visually you have your drawing to the screen. Your game state is going to be updating at some rate, and your drawing is going to be happening at some rate. But what you don't want to do is tie those rates together, because when you tell the canvas to draw, the browser is going to maybe take its time. You don't know in advance how many FPS you're getting. If you use tabbed away, you might get very, very low FPS. So your draw loop should not assume that your game logic is running at the same speed as your draw loop. And one way to deal with this is actually just have two completely separate loops. So let's use setInterval. This is a JavaScript function that sets up a thing to say, call this function about this often. And there are all kinds of reasons why it might not be that often. So we can't trust the exact timing of it. I'll show you how to deal with that. But it at least sets up to call it pretty often. So let's do on frame interval. That's just a function name. I haven't written the function yet. And let's say this goes off every 120th of a second. So if we're going for 60 FPS, we're going to get these faster than our actual frames. I like doing that just to have a little extra wiggle room. So we set the interval, on frame interval, 1000 over 20. And we're also going to need to keep track of time. So let's do this. Var last frame time. Alright, I have a variable that's global called last frame time. Let's say last frame time equals performance.now. Performance.now is a JavaScript function that just checks right now what time is it. So like it has been, if I type this, it's been this many milliseconds since I first loaded the page. If we reload the page, oh yeah, I never declared this function, so if we load the page, get an error. But yeah, it's been this many milliseconds we load the page. It's not an absolute time, it's just relative to some zero that's roughly when the page was loaded, what time are we looking at? We are on the load, we get the time, and we set up this interval. And then in this interval check, what we're going to do is see if it's time for the new frame yet. On frame interval. Alright, so var now equals performance.now. If now minus last frame time is greater than number of milliseconds per frame. So we're going to have a concept of FPS, and let's make that a constant. Const FPS equals 60. So we want to run this thing every 60th of a frame, 60th of a second. So hopefully we only get one frame every time we call this thing, but if there was lag, we might actually get them chunked together. So we're going to assume that that's a possibility. Let's be clever about it. So while now minus last frame time is greater than 1000 over FPS, these times are in milliseconds, so 1000 over FPS is the milliseconds for 60 frames per second. Alright, so while this time is the thing, we're going to advance game frame. That's another function I haven't written yet. And we're going to last frame time plus equals 1000 over FPS. So last frame time isn't the actual time we did the last frame. It's the time we would have done the last frame if everything were running perfectly smoothly. And it's possible that if we've skipped multiple frames, we'll have to go through this loop several times before last frame time catches up. Now, there is a problem here. If the user tabs away, it's possible this interval will get called at a really slow rate, like once a second. And that could be annoying. We don't want to do too many loops. So var times looped equals 0. And times looped less than, let's just say we can chunk as many as 5 frames at a time. Plus plus times looped. And then if we did loop that many times, then we don't want to keep last frame time to a low value and have the same problem again next time. So you just want to cut ahead. So if that happens, we just say, all right, forget that tracking the time cleverly. Let's just say the last frame time was now and start counting over from now. This is kind of a subtle timing point, maybe. This isn't the only possible way to do it either. It's just the way I've learned to do it that works well. I made a mistake here, of course. That last frame time equals now should have been in an if block, so it only happened if times looped actually reached 5. The way I have it, the timing is not correct, but it's still close enough that the rest of the demo looks okay. Basically, this interval makes sure that we're frequently checking the time, and if it's time for a new frame, we do one. If it's time for several new frames at once because of lag, we do them all at once. And if it's time for a lot of new frames, we just do up to a cap and then stop instead of doing too many. This is just for advancing the internal logic. This is not the draw loop. This is the game logic loop. Let's just have a little bit of game logic then. Var game frame number. Let's say game frame number is 0 when we start. So this variable is just going to be representing the idea of game logic temporarily until I have real game logic. Advanced game frame. So let's say game frame number plus equals 1. I am assuming you know JavaScript syntax, obviously, even if I'm explaining the individual functions. You know, like, what commas and parentheses and shit are. If you don't know those things, then this is probably not as helpful as it could be. Alright, advancing the game frame. So when we call this the game frame, note to keep updating. Let's just try it. Alright, so if we ask the console now, game frame number. Yep, that number is going up. So that's good, but nothing is actually getting redrawn. If you don't have this window on by default, which you shouldn't, this is going to be Control-Shift-K in Firefox, Control-Shift-J in Chrome. And then you might need to hit console to get to the part where you type in JavaScript. Typing JavaScript directly into the running page is very useful. It's actually one of the reasons I like using JavaScript for small game development at all. Another reason is because you can share the game without needing an executable. We have the draw loop. Now let's do we have the logic loop. The logic is just adding one to a number, but we have it. So now we're going to do the draw loop on draw frame. Okay. Function on draw frame. So request animation frame tells the browser, hey, when you get a chance to draw to the screen, do this on your way to drawing to the screen. That's going to be 60 FPS on a typical desktop browser under good conditions, but it could be some other number entirely. I'm not aware of any browser that does it faster than 60, but even so, just to be on the safe side, let's add another variable actually. Var need redraw. And when we do an advanced game frame, need redraw becomes true. And on an odd draw frame, we only actually bother drawing if we do need a redraw. But request animation frame isn't like set interval where you call it once and it makes a loop that always calls this thing over and over. Request animation frame just triggers once. So at the end of on draw frame, whether or not we actually redrew, we request another on draw frame. From here, we have our game frame number. Let's use that as part of an animation. Let's just take this code here that we were drawing the canvas like that with, put it in our redraw loop. After we draw, of course, need redraw becomes false. That's the whole point of having it. So we only draw when we actually have some change in game state. Now let's just say the box's X position is the frame number. Alright, so this should be advancing the game frame number at a smooth 60 FPS, drawing as much as possible, which should also be 60 FPS, and the box will have its X position based on the frame number. So there we go. We have a very simple animation and just a couple screenfuls of code. And that's the idea of how game logic works, except, of course, that there's no game logic yet. It's just one number. Let's make it slightly more interesting by adding some keyboard commands. So, I'm going to have to track some keyboard info. This is one of the things where I usually do some cutting and pasting, but we don't have to do cutting and pasting. Let's just say we have this thing, keys held. It's going to be some kind of var. Let's set it to be a empty object to start with, so we can do stuff with it. And now, let's add a handler. Window dot on key down equals function E. So whenever someone has the window focused, they start pressing a key. This function will get called. E will be a thing telling us about the key. Let's say keys held e.code equals true. So if e.code is key Q, then this will set keys held dot key Q to true. And likewise, when they let go of the key, we want to know about that. So let's say that sets it to false. And on blur, if they are tabbing away while they're holding down a key, we want to assume they're not holding the key anymore. Otherwise, it might get confusing if they let go while they're tabbed away and we don't see the key up. So, keys held equals an empty object again on a blur. So that should do something. Now let's just check if that works. Keys held. So these key codes are kind of magic. You just need to know what they are. The letters are all just key in the word. So red, green. The color codes are also magic, but I'm assuming you know HTML color codes a little. So, if we do this, the color should change to, yep, I'm pressing S and it's toggling the color. So we're getting keyboard commands already. Awesome. Now, let's say we have var demo sprite. Let's just call it something. And when we load, we set demo sprite to width, I don't know, 64, height 64, whatever, x 100, y 100. Actually, let's call this left and top so we don't get confused about which edges we're looking at. Alright, now when we advance, if keys held, let's use WASD, demo sprite.y minus equals 1. So if we're holding W during a frame, we're going to subtract 1 from the Y of this demo sprite object. Likewise, we can just have S do its thing. Oh wait, I called it left. I called top instead of left though. So let's make that top. Left, key A, key D. And then now that we have this object holding a bunch of coordinates, demo sprite.left, demo sprite.top, demo sprite.width, demo sprite.height. Alright, now when we do that, we should see that the sprite is not showing up. Okay, why is the sprite not showing up? Let's see. Demo sprite. It has a width, it has a height, it has a left half, a top. On draw frame is doing a thing. Well, this is good. This is giving me a chance to do a little bug finding. Alright. Let's just do this. Take these parameters here and also, let's say, console.log. Console.log is your basic throw thing at the debug console command. Alright. So the problem here looks like peculiar. So I'm saying I'm outputting left top with height. Left is 100. Top seems to be the entire object. Width is the window. So I screwed something up really funny. Okay, demo sprite dot top, demo sprite dot left. This is interesting. Did I refer to demo sprite somewhere else than where I'm thinking? No, minus equals, plus equals, minus equals, plus equals, left, top, demo sprite. Oh, I see. That comma there should be a period. So I was asking about the wrong thing entirely. Demo sprite dot top, not two different objects, one of which is the demo sprite. Okay. So now we have a square that if I use WASD moves, and also I'm still have the code that if I press S it changes color. Alright, that's not too bad. It's boring, but it's obviously I'm controlling the thing. This is the start of how a game might work. But let's add a little extra. Let's give it a velocity. Let's say its x velocity is 0, its y velocity is 0. Let's have a little gravity. Demo sprite.yv plus equals, I don't know, 1/16, whatever. Alright, and then instead of adjusting the, let's adjust the velocity, I don't know, I'm just making it up. So the velocity is going to go up a little all the time with gravity, the y velocity, up being down on the screen. And if you're holding W or S, you adjust the velocity. And if you're holding A or D, you adjust the velocity. So this is going to look kind of silly, but let's do it. Demo sprite.left plus equals demo sprite.xv. Top plus equals demo sprite.yv. So now we should have a thing with some sense of physics and momentum to it. Yep, it's moving. Oh, right. I need to hold down W. I lost it. Let's try it again. Okay. So yeah, now I'm moving with momentum. Just keeping the thing kind of on screen is already feeling vaguely game-like. This could be a Lunar Lander type game where you have to hit a target carefully and avoid obstacles. It already has some weight and momentum. There are some things that aren't perfect, though. You can't really see it. You definitely wouldn't be able to see it after video encoding. But I'm calling this fill rect with numbers that aren't actually round numbers, which is actually kind of a bad idea. So we want to make that round the left and top. And the width and height can just be whatever. That's those are always integers because I've never changed them. So those don't need to get rounded. So now that looks exactly the same, but internally we now never sending a draw call with fractions, so we don't have to worry about anti-aliasing and stuff. Another problem here is the velocities are probably a little too high, and also the thing just flies off the edges of the screen. Let's change that. If demo sprite.left is less than minus demo sprite.width, then demo sprite.left plus equals canvas.width. So if we are left by more than the size of the sprite, we'll just go ahead and teleport over across the screen. Let's make that plus demo sprite.width. So I think that'll be the right distance to teleport. If not, we'll see. Let's see if that does anything different. So now if I go left, yep, I can wrap around the left. And likewise, I could wrap around the right. Let's see, if I am greater than canvas.width, I could subtract those values. And that should give me a nice little, yep, that gives me a nice little on and off wrappy thing going on. Alright, now, if we go super fast, we had another problem. And this is strobing. We are now moving so fast that our position no longer overlaps itself between frames. Sometimes that's okay, sometimes that's not okay, but it's definitely at least a visual anomaly. And it also leads to trouble physics-wise, because you might just go through a wall because you never actually intersect the wall. So, if demosprite.xv is greater than, I don't know, 10, demosprite.xv is 10. And if xv is less than 10, then it's less than minus 10, then it becomes minus 10. And if we reload, we see now there's a maximum to how fast I go horizontally. There's still no max to vertical, but without a wrap, it's hard to build up that much speed. I would still eventually want to put a cap on just to avoid weird bugs if the user does something silly. But we now have an X wrap, have some gravity, have momentum. So this is pretty decent steps towards making something game-shaped. If you like squares, which I do, but it doesn't have to be a square. We can do better. Yeah, let's make this not a square. For that, we need an image editor. Well, there's a lot of things we could use. We could do it by writing JavaScript that draws the thing, but let's do a sprite. Because sprites are fun, and sprites are easy, and sprites require a program to write them in, which sometimes takes a little longer to load than you'd like. Okay. I happen to be using GIMP. It doesn't matter. All that matters is I can get a transparent background out of the thing. Anything that can save a PNG with transparent background is fine. Alright, let's make a sprite sheet. Alright, I want a pencil tool. I want a grid. I don't really need a grid necessarily, but I'm just going to make a fucking grid. Alright. Let's see the grid. Alright. I want my pencil tool to have a small brush. I want to use some colors. I don't know. I don't care what this is. I'm just showing that a sprite can be made. So I'm just going to make this weird potato-y blob thing. Do a fill. I actually left the bounding box a little. Yeah, this will do for demonstrating. And let's make an animated sprite by just taking this, moving it here, and maybe what do you do for animation? I don't know. How about give it little eyes. Copy them over. And this other frame, maybe the eyes are like flashy. Like the eyes are going to flash red, because why not? I don't care. I just want to have some kind of sprite. Alright. Now, let's go back over here. We want that sprite sheet to show up. So image, ID equals sprite sheet, src equals that file name, and style equals display none, because we're not actually putting it on the page directly, we just want it to reference from the JavaScript. Alright, so now we have this image called sprite sheet. OnLoad won't fire until it's done the best it can to load this sprite sheet. So as soon as we hit OnLoad, we know we can reference it. Alright, so let's have a var sprite sheet. Let's have, while we're getting that canvas, let's also get the sprite sheet. Sprite sheet equals document blah 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 sprite sheet. Okay, get element by ID sprite sheet. Sprite sheet. Okay. Now let's add a new parameter to the demo sprite. text x equals text top. Let's keep that consistent. Text left equals 0. And then when we're going to do this, now we're no longer filling a rect. Now we're going to do this. Context.draw image sprite sheet. Demo sprite dot text left. Demo sprite dot text top. So draw image can be used a few different ways. You could use it to draw part of an image, like using just the sprite sheet as a sheet and not drawing the entire sheet at once. You give it 9 parameters. The left, top, width, and height of the sheet position, followed by the left, top, width, and height of the actual place on the canvas you're drawing it to. So we do that, and we don't need that fill style anymore. It's no longer using fill style. It's just going to be doing a copy of the image. And if we reload now, we get an error because line 23 opened a curly brace and line 30 didn't close it. Line 23, I had semicolons where I should have had commas. Right, yet I had equal signs where I should have had, right. I work in multiple languages, so I sometimes forget the syntax of one language at a time. Alright. And now we have the sprite, frame 0 of the sprite. Let's provide frame, let's use this frame too. Let's use this frame. How about this? Really simple way of doing this. If demo sprite.top is greater than canvas.height times 3/4, demo sprite.text top text left equals 64. I use a 64 grid, right? Yes. Alright. And if demo sprite top is less than canvas height over 2. So what I've done here is the sprite is now holding these text top and text left variables, telling where in the sprite sheet should you look me up when I'm drawing. And in the game logic, I'm telling it if I'm below this height on the screen, then I want my texture to start coming from this point, and if I'm above this height, I want my texture to start coming from this point. Between the two heights, the texture will just stay wherever it was. So we should see when we're falling, yep, when we're falling and it gets dangerous, the eyes glow, then we raise up and the eyes stop glowing. Not that it's actually dangerous since there's no penalty for falling off the bottom, but the idea here is it could be. We could easily have some code where you hit the bottom, a lives number goes down, you have little lives on the side of the screen that deplete, switch to a game over with a completely different thing that happens when you're on the game over screen, etc. Alright, so this is the essentials of how a game in HTML and JavaScript can get started up. Obviously, there's a lot more depth to be done in the game logic, just having one sprite object, but all the pieces are here. You can have multiple sprite objects, compare their positions to see if they're touching each other, have them react to their positions, have lists of sprite objects, use a for loop here to draw them all. But for this video, I think this is where I'm stopping. I will make more videos like this in the future, very, very likely. I already have an idea for the next one. So, there we go. Goodbye.